So I'm walking us through this model of poor health and disease progression. Now, this is a model that I developed to help us understand the general story of the modern human body. Okay, so once again, I have to say this model isn't supposed to describe every individual's health story. What it does aim to do is to describe the story of what most individuals will go through in their lifetime just because we happen to live in the age we do, right? Where we tend to eat industrially processed foods and we tend to have sedentary lifestyles and we tend to just have a huge load of stress in our day. So that's what I'm aiming to capture with the reprogrammed systems model. And in this video, we're going to dig into sort of the key piece of it. That's this idea of energy dysregulation as a key driver of poor health and its progression to disease. So when we talk about energy regulation, right, how is energy regulated throughout the body? Now, there are many different factors involved there. We can talk about a bunch of different hormones, a bunch of different organs, different brain regions, right? There's many pieces at play here. However, there are some factors that play a much more significant role than others, especially when it comes to thinking about the actions that we perform each day. Now, there is one particular factor that I have come to see as playing sort of the most significant role in driving the progression of poor health towards disease, and that is insulin. So insulin is our body's pro-energy storage hormone. So when we consume food, insulin elevates, and that tells systems throughout the body to store energy, but more specifically to act in a way to lower blood sugar. Now, we're going to get into all of this here, but you can think of insulin in those two roles, right? One is it is the body's primary pro-energy storage hormone. Insulin elevates, the body tends to store energy away. Insulin is low, the body will then release that energy. Insulin is also elevated. Sort of the primary reason it's elevated is because blood sugar is elevated, right? We consume food, blood sugar concentration elevates, and that tells the pancreas to release insulin. Now, what I'm going to do in this video is walk you through why the dysregulation of insulin is what I have come to understand as this key driver that is driving the state of metabolic dysfunction that half of our population is already in, right? And as we know from the model, this metabolic dysfunction that keeps, right, we keep driving this pathway forward, and that's going to eventually lead to the arising of clinically relevant symptoms that we then label as disease. So let's dive into this. And to do so, we're going to focus in on one particular subsystem, one that we are all familiar with and probably most interested in, and that is our adipose tissue, our body's primary site of fat storage. So adipose tissue, pretty simple cells. that are designed to expand to take in energy to store as fat. Our adipose tissue interacts with our circulatory system, right, blood vessels. So when we consume a meal, blood sugar elevates, right? We get glucose in the bloodstream. We also have, say, fats in the bloodstream. The glucose is released into the bloodstream, and that is going to lead to the elevation of insulin. Insulin elevates, and that tells adipose tissue to take in this energy and to store it as fat, right? It takes in fat and stores that as fat, of course, but it also takes in glucose and stores that as fat. Consume a meal, insulin elevates in response to elevated blood sugar. That drives the bulk flow of energy into storage in adipose tissue, which we may get a little squeamish about because our society has decided that accumulating fat is a bad thing. But this is actually a very good thing. We need to be able to store away energy, because when we stop consuming food, insulin drops back down and we have lower energy out in circulation. We need our fat cells to release this energy. Okay, now it's going to release fat out into circulation so that the body has energy that it can use, right? We can't be eating all the time. We don't want to be eating all the time, right? We have so many other things we want to do during the day. So this very simple system here is so important. And insulin's role in it is so important. However, what happens if we take this insulin signal and we turn it on and we never turn it off? What if we just keep eating food all day long? Right? What if we wake up and the first thing we do is we have a bowl of cereal? And then what if an hour or two later we decide we need a snack? Then what if an hour after that we decide it's time for lunch? And then an hour or two later we need another snack, right? What if we just keep eating day in, day out? Well, the insulin signal is going to stay on, which means the bulk flow of energy is going to be driven into storage. Okay? We keep eating food and the bulk flow of energy is driven into our adipose tissue. What if we decide then, okay, I think I'm a little overweight. I could lose some weight to be healthier. Well, traditional wisdom tells us just eat less, right? Just eat fewer calories. Okay, so what if now I'm eating fewer calories throughout the day, but I'm keeping this insulin signal on? Maybe I eat a little less cereal in the morning. Maybe I make sure my snack at 10 is only 100 calories. Maybe I skip the bag of chips at lunch, but I still consume a sandwich. right? What if I then have another snack and another meal? I may be eating less overall during that day, but the insulin signal has stayed on all day, which means the bulk flow of energy has been driven into storage all day long. The bulk flow of energy is being driven into storage. How is adipose tissue supposed to release that energy, right? Because that's what we want to do. We want to lose weight. What we really want to do is lose fat mass. We want to take the energy stored in adipose tissue and drive it out into circulation so that it can be used as a fuel source. But if the insulin signal stays on, the bulk flow of energy is being driven into storage, not out of it, which means that this fat tissue is just going to keep expanding. At some point, what's going to happen is this is going to expand so much that a certain threshold is reached. Now this threshold, it's going to vary depending on the individual, right? Depending on your own genetics and other factors, your ability for your fat tissue to expand is going to differ, right? And that's why one individual can weigh a certain amount and be perfectly healthy, while another individual may be what society has deemed completely acceptable and yet be completely unhealthy, because we each have our own threshold of fat tissue expansion. Now, once that threshold is reached, then the adipose tissue is going to sort of send out this help signal, right? It has reached its capacity. It can't keep taking in more energy. So what's going to happen is it's going to become inflamed, right? And it's going to send out these pro-oxidative, pro-inflammatory signals. And what that's going to do is make the adipose tissue insulin resistant. So we keep the insulin signal turned on day in and day out. The bulk flow of energy is driven into storage in adipose tissue. It's going to keep expanding until it reaches a certain threshold at which a pro-inflammatory, pro-oxidative signal is going to be released. And that's going to make this adipose tissue insulin resistant. Insulin resistant adipose tissue, it's going to stop listening to this insulin signal. Okay, so we'll keep consuming carbohydrate, the insulin signal is elevated, but now the bulk flow of energy isn't going to be driven into adipose tissue. Adipose tissue has stopped listening to the insulin signal. The bulk flow of energy isn't driven into storage here. Well, what's going to happen? This energy needs to go somewhere, because when energy is elevated in the bloodstream, this can turn into an acutely life-threatening situation, right? This is why diabetes can be so, it can be life-threatening if it's not managed, because blood sugar that elevates in the bloodstream becomes acutely toxic. So if that energy isn't being driven into storage in adipose tissue, it has to go somewhere. Okay? Now we can continue down this pathway, and I'm going to in other videos. Right now I want to keep our attention here on this one particular subsystem. So at this point, we have a dysregulated system. Adipose tissue is supposed to listen to the insulin signal. However, the insulin signal has been turned on in a chronic pattern such that adipose tissue has reached capacity and become unhealthy. It's become inflamed, sending out a pro-oxidative signal, and it is now insulin resistant. The insulin resistant adipose tissue, that's going to protect itself, right? Because it can't keep taking on more energy. So it needs to become insulin resistant so it stops taking in more energy. But the fact that it does means that energy is now elevating in the bloodstream, which is a life-threatening situation unless the rest of the body responds. This here is one pathway through which we see energy dysregulation leading towards metabolic dysfunction via the chronic elevation of insulin. Now I begin here, one, because it's a pretty simple model for us to understand. Insulin turned on in a chronic pattern, bulk flow of energy goes to storage. We lower insulin, now the bulk flow of energy can be released. I start here because this is very tangible, right? We perform different actions day in and day out that directly impact insulin levels in our bodies. The type of food we eat is going to be the most significant impactor there, right? Insulin is elevated in response to elevated blood sugar. Blood sugar rises when we consume carbohydrate. However, it's not enough to just say that to lower insulin, we should just do away with carbohydrate, right? That's one way we can think about it, but it may not be the most practical, depending on the individual, okay? So what we want to know is a little bit more about how our decisions directly impact insulin levels in the body. And that's something we're going to keep talking about because it's not something I can cover in the next couple of minutes here, and I want to wrap things up for today. But the point here just being, if we can understand this simple model, we then have the ability to have a significant amount of control over insulin levels in the body and how that impacts our fat tissue and the health of our fat tissue. Keeping in mind that it's okay, it's good, it's healthy to temporarily elevate insulin. It's a good thing to be able to store away energy as fat because we need that fat as energy when we're not eating. The problem is the chronic elevation of insulin, driving the bulk flow of energy into storage and not allowing that release of energy out into circulation. So I'm going to wrap up things here. In other videos, we can talk more about how our decisions directly impact insulin, and we can also follow along this pathway to see what happens downstream when insulin or when energy is elevated in the bloodstream, right? What's happening at the site of the liver or at the site of the muscle? Because when we are making decisions in our life, we don't want to be hyper focused on our adipose tissue, which is what our society really is right now, right? We want to keep the health of our entire body in mind. So we'll talk about that in some other videos. I hope this one was helpful.